All right, guys, it's Friday the 15th. This is my last warm up of the 2019-2020 school year. Sad. Okay, here we go. Another example of a stoichiometry multi step problem. A student placed a piece of nickel in silver nitrate solution. Silver metal precipitated. The student collected the following data. So, step one, we're going to write and balance the chemical equation that summarizes this experiment. So I've already done that for you. Nickel is obviously Ni. It's solid, reacts with silver nitrate, a +1 -1, solution, aqueous, to yield silver, which is solid, plus nickel nitrate, which is aqueous. Now in this particular reaction, even though I gave you the equation, this is not a balanced equation. So you would need to account for the 2 nitrate and the products by putting a 2 in front of your silver nitrate, which means that you have to account for that over here in the products by putting a 2 in front of the silver, right? So I don't know why there's not a whole lot of space here, so I'm going to do this on the next page, hopefully. Yeah. All right, so step 2, we're going to go ahead and calculate the theoretical yield of silver. And this is going to be a multi-step stoichiometry problem. And we're going to go ahead and start with the amount of nickel that reacts, right? So in order to determine the amount of nickel that reacts, we need to know the mass of the nickel before the reaction and the mass of the nickel after the reaction. So we're going to go ahead and subtract 5 grams minus 4.69 grams, and that tells us that we have 0.31 grams of nickel that are reacting with the silver nitrate. So we're going to convert grams of nickel to grams of silver, but we can't do that without relating the two with moles. Okay, so I'm going to do that, like I said, on the next page because I'm going to run out of space there. So I'll rewrite my balanced chemical equation for you. While I'm writing this, you guys should recall that this is a single replacement reaction or a redox reaction. There we go. Okay. So like I said, we know the initial amount of nickel is 0.31 grams. And we need to know how many moles of nickel react in order to be able to relate moles of nickel to moles of silver, right? Because we have this balanced chemical equation telling us that for every 1 mole of nickel, there are 2 moles of silver produced, okay? So the only way to relate these reactants to products is with the mole ratio. So I would need to know the molar mass of nickel to be able to convert from grams to moles. So use your periodic table. Bada bing, bada boom. And we've got grams of nickel that cancel, and you're left with a whopping, not very much, I'm going to run out of room here, 0.0053 moles of nickel. Okay, which is great, but that's not what I want to know. I want to know how many grams of silver are produced. So I have to somehow get from moles of nickel to moles of silver. And I'm going to do that with my mole ratio. So I know for every 1 mole of nickel in this reaction, there are 2 moles of silver produced. So I'm going to have twice as much, a whopping 0.011 moles of silver produced in this reaction. Okay, which is great. So we've gone from mass of nickel to moles of nickel, and then from moles of nickel to moles of silver through the balanced chemical equation. Now we want to know, okay, how much silver was actually produced in grams. So now we can convert from moles of silver back to mass of silver using that 107.87 grams, which is molar mass. And I get 1.19 grams of silver. Okay. Well, that's all well and good. That's my theoretical yield of silver. So if all things went perfectly well without any experimental error, I should expect to yield 1.19 grams of silver. Now, in the real world, there is experimental error. So perhaps you didn't fully react all of the nickel in the silver nitrate solution, didn't wait long enough. Who knows? Mismeasured the initial mass of the solution. Okay. In either case, we are going to refer back to our data to determine what the experimental yield actually was. So to calculate experimental yield, we need to know the mass of this beaker with silver. And we're going to go ahead and subtract from that the mass of the empty beaker, because we just want to know what the mass of the silver is at the end of this experiment. So we're going to go ahead and take that 103.13 grams and subtract from that the 102.05 grams. And we're going to go ahead and determine that our actual experimental yield is 1.08. Okay, so it's a little bit less than the theoretical. So to calculate percent yield and then determine basically percent error, what we're going to do is we're going to take our theoretical and we will subtract from that our experimental from our data above, divided by theoretical times 100. And I'll go ahead and let you guys do that because I'm filming this the same day as the other warm-up and I forgot my calculator. But I'll set it up. 1.19 minus 1.08 divided by 1.19 times 100. You're going to get a positive percent yield, meaning you're a little bit higher than the expected, or sorry, a little bit lower than the expected theoretical yield. Okay. I think that wraps it up for now. Think about some of the experimental error. Like I said, perhaps you didn't wait long enough for the nickel to fully react with the silver nitrate, so there was still excess nickel left over. So what was expected was actually less than the theoretical. So think outside the box as far as experimental error is concerned. All right, I think that wraps it up for today. And have a wonderful weekend. On Monday, I will be emailing you individually with a set of lab data and instructions on how to complete the final assessment of the school year, which is a lab similar to the magnesium and air lab. So stay tuned for Monday. You should see an email in your inbox with a set of data and instructions. All right, take care. Bye.